Number 20. An electrical motor spins at a constant 2,695 rotations per minute. If the rotor radius is 7.165 centimeters, what is the radial acceleration of the edge of the rotor? So here's our spinning rotor. It has a radius of
7.165 centimeters.
So we'll call that 0.7165, 0.07165 meters. And its omega is partially given to us because they tell us that it's spinning at 2,695 RPMs. So let's go ahead and convert that.
So do we need to change that to radians or keep it to?
Yeah, for this one, since we're going to probably be using kinematic equations, we'll probably want to get, it's worth our time to get into the standard units.
Okay.
So we've got this many revolutions per minute. We know that in 1 revolution, there's 2 pi radians. We know that in 1 minute, there's 60 seconds. So we've got revolutions canceling, minutes canceling, we're left with radians per second. So I got 282. Radians per second. Cool. And it's asking for the radial acceleration on the outside of the rotor.
Yep.
Okay. We've got some point on the edge of our motor. It's traveling at constant rotational speed, which means that it's not accelerating rotationally. So it has its alpha would be 0 radians per second squared. But it still has to have accelerational or centripetal acceleration, or sometimes called radial acceleration, because it's got to have some force pointing in towards the center of the circle that keeps it turning. Because otherwise this rotor won't just shatter into pieces and everything fly out in straight directions, because things don't like to turn if they don't have to. So something has to be forcing it to turn. So that's our radial acceleration. And this is kind of an old equation, but we learned that centripetal acceleration is equal to v squared over r. Remember that? So we know what r is, so we just need to get velocity, linear velocity, and then we can plug into this equation and we're good to go. So right now we have omega. So if we remember that v divided by r gives us rotational velocity, then we can remember also that rotational velocity times r gives us linear velocity. So we'll go ahead and take this number, the 282 number, times, yep. So I got 20.22. So 20.22 squared divided by 0.07165. So I got 5,706.8. That will be in meters per second squared.
Yep. Okay. That makes sense.
Yeah, that one, it's kind of like a kickback question, because this is some stuff that we haven't talked about in a while,
Yeah.
radial acceleration, but it's a good question.
Hmm.
Any questions with that?
Okay, nope,
Cool.
got it.